Hello, my name is Alex, and today I'm going to be giving you an introduction to CursusDB. All right, CursusDB is a distributed NoSQL document type database management system, and yeah, we're going to be going through these slides, and we'll go over a basic local setup. I'm following along with the documentation later. So let's go to the next slide. I'm going to skip that previous slide. Just goes and says that CursusDB was initially designed by myself. I'm Alex Gaetano Padula, and it's licensed under the GPL 3. Okay, so CursusDB is open source, obviously, because the GPL. It's a document-oriented database, meaning that it takes JSON type documents, very simple JSON type documents. So no nested JSON objects. You can have arrays, so your JSON objects can have, arrays of integers and strings and what have you, booleans, but it cannot have nested JSON objects within a document. NoSQL, it's distributed. We'll go over the distributed piece here whilst we go over these slides and set up locally. You'll see how a cluster and a node is separated. So the cluster doesn't actually contain your data, the nodes do. CursusDB is cross-platform, meaning it supports Linux and Windows and OS X, BSD, and so forth. It's an in-memory database, which is persistent to your hard drive as well. And it's secure by default. And we'll go over that in a bit. So if we were to cross MongoDB and MySQL, CursusDB would be the unstructured distributed baby. All right, just a little thing there. All right, so CursusDB has, it's built on top of a cluster and a node. So the cluster you can think of as a communication hub for the clients. So you from the node native package or from the shell, from Curush, which we'll set up later, can communicate with your cluster and send different queries, and queries are actions that the cluster sends as requests to each of your nodes in parallel. Each node is, let's say, a shard or a section of whatever collection you set up. All right, so let's read through this. Cursus. Cursus is the cluster. We call Cursus the cluster. A cluster is, as I stated, is the communication hub in which communicates with a bunch of your configured commodity nodes, commodity or not. And corrode is a cluster node, which can be a replica or just a main node. And yeah, it stores sections or shards of your collections, which live in memory and on shutdown or on backup get rested into a CDAP file, which is encrypted and compressed. All right, the encryption is done with cha-cha, and the compression is done with deflate, the algorithms. It's a document storage, so well, here I just labeled document storage, but so your documents are stored within collections. So similar to MongoDB, you can have a user's collection, but within this user's collection, you can have unstructured documents. So a user can have a first name and a last name, but another user can have a first name, a last name, and an age, unstructured. All right. So no schema, no model to your collections. So within your nodes, your data is in memory for fast access and for the searches to be done obviously faster than reading through a file and whatnot, right? So in memory access. So secure by default, what I mean by there is right when we set up a cluster and a node, we set up an initial user and a shared cluster and node key. So there's no defaults that a bad actor can can get your server, and if you accidentally make your server public and you have the defaults, and then they get access, and a whole bad bunch of things can happen, right? So we just avoid that. So Corrode, the CursusDB node, has the availability to automatically sync to your read replicas and automatically backup and clean up backups and automatically recover. So by default, Corrode will synchronize data to a read replica by default, every 10 minutes. But this can be configured. Automatic node backups. If you have this configured, Corrode will back up .cdat files with a timestamp. So, by default, Corrode will back up every 60 minutes, but you can set up to whatever you want, 360 minutes, 1,000 minutes, whatever you want. All right, but it's going to automatically back up CDAT files. So in case your database ever fails or there's a power outage or anything like that, you have backups of your charts. And Corrode can automatically recover to the latest known working state of a backup. Okay, cool. So CursusDB has its own query language called CDQL. It's similar to MySQL, but very simplified. CursusDB is really made to be simple and easy to use, and right, so simple. Let's just keep it simple. KISS. All right, let's go. So we have the insert. Here we're inserting into a user's collection, and as you can see, in between the parentheses we have a JSON object. So that's how CursusDB will take an insertion, right? It'll look in between these parentheses. It'll look at the collection. Okay, so we're going to insert into the collection, and we're going to insert this document in between the parentheses. Now, as I stated before, it has to be a simple type JSON document, so no nested objects inside there. Okay. Now, you might notice the email has an exclamation point. What does that mean? Well, the exclamation point means, hey, check in this user's collection if there's a user already existing with an email of alex@example.com. Now, CursusDB is distributed, so you can have many nodes, and there are many parts of your collection, right? So a user's collection it can be distributed in between 3 nodes, let's say, right? But the exclamation point will make sure that value is unique across all your nodes for that specific collection. Okay, very cool, very simple, very easy to use. You'll get an error if you get a duplicate document error if you try to do that, because it'll say, hey, you're gonna put in a duplicate here, and you said, we have an exclamation point here, so cool, very cool stuff. All right, so the selector delete, very similar to MySQL. We select all from users. Here, we're selecting one. All right, we're selecting one value. There looks like a space here, but you can't have a space here. Make sure there's no space in between the 2 and the comma and the 1. Okay, but we're skipping 2, and we're selecting one value from users. Here, we're skipping 100 just from there's no conditions here. We're just saying select all from users, but skip 100. Here we're saying select all from users, order by first name descending. So what does that mean? Well, it's going to order by alphabetically, essentially, by the first name, ascending or descending. Here we're selecting all from users or first name like with the letter A. So any user that has a uppercase A starts with an uppercase A. You can really look in the documentation with the pattern matching there. Here we're limiting it to 1, so select 1. There's a lot you can do here. You can have endless conditions. It's a very powerful language, query language. Update, very similar. You have the set, so update 1 in users where first name is equal to Alex, and set the first name to John. So this is the basics of CDQL, and we'll go over the basics of getting collections and seeing your database users, and there's other pieces to CDQL, but this is how to essentially insert data, select data, delete data, and update. So you see here I write select or delete, because you can say delete all from users, delete 2, skipping 2 from users. So yeah, let's go on here. So these are just some features. I'll let you, if you want to read through that, you can. All right. Or you can just pause back there, right? So you can just pause. All right. So there are no databases like MySQL. So a cluster is your database, okay? So if you load balance your cluster, right, the cluster is your database that is separated and I mean, sorry, spread across many nodes, okay? So think about it like that. I always think about it like, okay, I think about it like just many computers that store your data, and you have one or many central computers that access your data, right? That's how I think of it. So here's a little technical drawing that shows this is you as a superhuman, and you're selecting all from a collection, and the cluster is simultaneously creating a parallel search. Okay, so it's saying it's requesting from node 1 and it's requesting from node 2 simultaneously, and they're both doing their searches simultaneously, and then essentially returning the values back to the cluster, and you're getting the values back. And this is just some stuff about the synchronization and the nodes on shutdown, how they get rested into CDAF files. And there's also a mention here about giving your operating system more time as your nodes grow, because on shutdown or on something like that, you do want to give your operating system a little bit more time if you have a lot of data, right? Because it is on shutdown. Unless you have backups and which we'll recover from, you just want to give your operating system enough time to do that, essentially like layover into a CDAF file. Okay. And here it just says that, if you have 10 million documents spread across 10 nodes, the cluster Cursus will aim to query 100 million in the time it takes to query 10 million. So if you have 100 nodes, now you have 1 billion records, okay, let's say, or 1 billion documents spread across all those nodes, and Cursus will aim to query all them in the time that it takes to query, 10 million. Okay, cool. Let's go on. So here's just an example of the insertion. So you're using a client, you say insert into users, right? And the cluster is going to pick a node at a random. So it can pick 2, it can pick 3, it can pick 1. But if 1 is not available, then it'll randomize again and try to not pick the same node, but another node, okay? Because it already tried that node. To insert, this one was not available, then it'll try this one, and so forth. Cool. So Cursus, the nodes, Curodes, have a unique way of searching through collections. It uses a top to middle and bottom to middle parallel search. So it'll initiate a search from the bottom to the middle and top to the middle, essentially doing its search. So instead of using binary search or linear search, it has its own implementation of a search. Okay. And yeah, then it leads to the documentation and the GitHub, which we'll be looking at and setting up in a local database, which is distributed locally for this example, right? So let's open up a terminal here. Dun, dun, dun. So I got a terminal here. And we're going to open up the documentation and work with that. So this is CursusDB.com. This is the Cursus GitHub. We got a bunch of native clients here for Python, Go, Java, C#, Node.js. There's a REST API template. Very good stuff here. Okay. But what we're going to be doing here essentially, so there's a lot of good stuff here. It goes over what we're going to be going over right now, and it gives you a little bit more of the query language that I was showing you in the presentation. It even shows you how to get counts, and there's a lot to the query language, as I said, right? So it's good to have a look at this or a look at the actual documentation when using the database. So let's follow this. So I'm on a Debian based system, so I can follow along with the downloading bit here. So I'm just going to copy this and just for your own note, the website documentation does have the latest version at all times. So this is the latest version, stable version. So we'll just do that. We'll say wget, no problem. Just do an LSA, see what we got in there. So we have some files in there. So probably from like some examples I did. See what we got in there now. Now we have nothing. So good. So we have the cursus, and let's extract it. Let me clear. I'll do LSA. So now we have the tar.gz and the cursus. So now we have the cluster, and then we're going to get the node here. And usually you would have this kind of set up differently, right? So you'd have the cluster on its own instance, the node on its own instance, and everything kind of on its own instance, right? But for this example, we're doing everything locally. All right, so we gotta extract that, clear, and this is the CursusDB shell, like I was mentioning before. We'll just get that, and we'll extract it as well. Okay. Awesome. So how do we get started, right? That's the question. Well, what I like to do is I like to just essentially start with the cluster. So I'm gonna say cursus, and we don't have a cursus config set up yet, which is a YAML formatted configuration file, but it's gonna ask us, hey, create your database user, your initial one, and give us a shared cluster key, shared node, and cluster node key. Sorry. So I'll just do that. And essentially now it says you must set up nodes for the cursus. Oh, well, the lettering here is a little bit off. It should be written a little bit different, but you get the point. So we'll open up cursus config here. And the default port for a node, okay, is let me do host. So we're doing local, and then we'll also have port 7682. So I'm just setting up a local node. The default port for Curod is 7682. So I'll just go save. So that's good. Now, if we try to start cursus again, it's going to say that it couldn't connect to the node, obviously because we haven't started it yet. So let's just open up a new tab here. And let's run Curod. And it's going to say, give me the cluster key, the shared cluster key that you set up in your node, on your cluster. So we'll do that. Okay, so there you go. So now the node is set up with a cluster key, a shared cluster node key, and it's running. So at that point, we can go back and run the cluster. Okay, so at this point, we can see that we have an info from the log. It's logging to standard to your standard output. Because we don't have logging enabled, we can enable it through cursus config, but we don't have that currently enabled. But it's saying it made a connection to the node, okay? And you can see here it had no previous data to read from the CDAT, so it created a new one, all right? And here the cluster made a connection to the node. So at this point, we're okay to get started. But I do want to show you something. If this node disconnects, for example, now you can see that we receive a signal to interrupt, and it's starting a database shutdown for the specific node, and it's starting to write the node data to a file. Okay, so now if we LSA, you're going to see that we have this CDAT. Okay, but we're also going to go here, and currently the node isn't connected, right? So I'm going to show you something interesting. If we go to Curush, and now we're going to start Curush here, and we're going to give it the cluster host, and we're going to log in with the cluster credentials. And I'm just going to say select all from users. Now you're going to see this empty array. Okay. This is because, okay, you're going to see this, that the node is unavailable. All right. Now if we restart this node, what's going to happen? Let's go back to the cluster. Lost reconnect, reconnect it to lost connection. So it reconnected to the node automatically, no problem. Now, as you can see, now we have null back from the node, which makes sense. And we have no users. So using the CDQL, let's insert a user. Insert into users. Let's insert a basic user. So first name, we'll say Alex. And we'll say last name is put my last name. And then let's see. We'll say email with an exclamation point is alex@example.com. So now we have a document inserted successfully. Now, mind you, the exclamation, we talked about this earlier. Let's try to reinsert this document. Oh, document already exists. So we cannot exist the same document. I mean, we cannot insert the same document because it already exists because of the exclamation point. Okay, it's doing that check for us. Awesome. So now we have a user in our users collection. Let's search it. Select all from users. So we have one user. As you can see, currently we don't have the results joined, right? We're actually seeing what the node is. Now there is a configuration in the Cursus config file that we can actually join the results of all the nodes, okay? But for this example, we'll just keep it pretty easy. All right, so let's say we want to update the first name of that user. I'll just say update one from users where first name is equal to Alex, set first name is equal to John. So we just say update one. Oh, I see where I messed up there. Update one in users, update one in users, sorry about that, where first name is equal to Alex, set first name is John. There we go. So now we got a one document updated successfully with a status code of 2000, and we have the updated document. And if we say select all from users, we get the updated document with a first name of John. Okay. So that's all good stuff. I want to go over some basic commands here, such as finding your collections and seeing your users. So very simply, users with a semicolon will show your users. Adding a new user, you just do a new user, and you give it the username, so Daniel, and then you give it your password, and then you give it the permission. You give the user the permission. So there's either read, which just gives the availability to read to just the availability to read only, so they can't really even read users. They can only read collection data. They can't do much more than that. All right, so just a read permission. This is read and write. So this is the admin permission. It's more administrative, but we'll just give this user read. So new database user created, and we can say, delete user Daniel, and then this will, oh, sorry about that. Delete user Daniel. This removes a user. If I want to see all the collections, I just type collections, and it shows me the collections. And anytime you insert into an unknown collection, we'll create it. And then when you delete all the records from a collection, it'll delete it. So I'll give you an example. So if we say insert into test, or let's say insert into posts. Okay, insert into posts with a title of post title, and then give this a body of hello world. Okay, insert into post, yeah. So it inserted the document into the collection. So now we have two collections here, post and users. Now if I delete all from posts, okay, and then we search the collections again, it deleted that collection because there's no more post existing, okay? Very simple stuff. As I said, the documentation has a lot of write-ups on how to set up a replica and how to connect the clusters, and there's a REST API boilerplate for Node. Oh, I didn't show you the most basic command, so ping. There's a very basic command, ping. But yeah, the documentations go over a lot of stuff with the database and how to do. Oh, well, I'll show you another piece here. So so as you can see in our users collections, if I select all from users, you can see that we have a last name here, a last name key within the document. We can say delete key from, or delete key last name from users. Oh, delete key. And, oh my gosh, I'm typing this wrong. In users, there you go. So as you can see, it says document key removed from collection successfully. So what that did is if I say select all from users, it actually deleted that last name key from every user document in the users collection, which is very cool, right? So we're altered, as you can see, it altered the documents. Okay. So this is a basic example of how to set up something locally and use Curush, the CursusDB Shell, to query the database and so forth. In the next videos, I do want to go over and show you how to set up like a Node.js REST API, and maybe go over the rest of the pattern matching stuff. There's a lot of stuff with the database to go over through in the query language. And yeah, it's well tested. So if you miss a piece of the query, it will tell you. Most of the time it will tell you what you're missing. Like here, delete key is missing in. It'll tell you what you're missing, and then you have to go, oh, delete key, and you have to go look and remember what you did wrong. But it catches those errors for you. The cluster does, Cursus, so very good in that part. And as I said, the cluster doesn't directly store your data. So yeah, if you have multiple clusters, so this is just an example. If you have multiple clusters, let's say, also on the Git and documentation, you have all the status codes and the reserved words. There's a benchmark here showing how fast CursusDB is compared to MySQL, for example, for specific things. Let me see here. There's one piece I want to show you. Okay. So if you have multiple clusters and one cluster is not communicating, I just want to explain a piece. Anytime you send, this in some cases could be called a single transaction or an action or a query, right? If you're sending multiples of these and you have multiple clusters and multiple nodes, it's really hard for any kind of query to fail, right? The only time a query would fail and not reach the nodes would be if there's no clusters available. All right, so I just want to explain that one piece. All right, and but that's all for this video, and I hope you take the time and give CursusDB a try. It's truly something awesome, and I developed it, designed it for my own needs, right, for my own projects, and continuously take on different ideas. And but currently the way it is, it's very stable, very reliable, very persistent, very fast. So I'd say give it a try. Let me know what you think, and I appreciate your time. Talk to you soon.